Now we will now hopefully finish up our review of linear equations. Of course, the hopefully part is because ideally you already know most of this, if not all of it. And then after this, we can continue on to the stuff about linear equations that we will be talking about for the actual grade 10 curriculum. Hence why this review is about linear equations, because we're getting right into it after. Now, point-slope form. Now, this is what happens when you take the slope and then apply it to a particular point. Why does this formula make sense? Well, let's say we have x, y. So we have a point somewhere. And why is it that we take m and multiply by x minus x1? Now wait a second. What's x1? So x1 is here and y1 is over here. M times x1. M times x1 is this part. So this is mx1. So if we had y equals mx plus b, well, what's a b? This here is b. So this little bit down here is b. So y1 is equal to b plus mx1. Well, what happens when we subtract this and this? So we get y minus y1 on this side. The b's cancel out, but mx minus mx1 simplifies, well, collapses out to this. So we note that this has to be a non-vertical line. Why? It's because for a vertical line, it's just x equals something. Well, we can use some variable. Various conventions might have you using a here or x1 or whatever. So y does not factor into calculations where you're trying to deal with vertical lines. Now, if you have point-slope form, then the 2 points form is one of the several point-slope forms, really. Because we know that the slope is rise over run, well, that means this can be substituted to give this. And these are the 2 points. Which order you list them in does not matter, because the symbols cancel out anyway. Now, let's do some examples. Write equations of the lines that pass through the given points with the given slopes, then write each equation in standard form. Okay, so it's through this point with this slope. We know that the formula is supposed to look like this. Now, this would give us y minus, which variable is listed first when you list a point? You list them in alphabetical order. So if the variables are a, b, c, d, e, f, g, h, i, j, k, and so on, you would list them in that order. Now here we have x, y, z as the typical 3 coordinates that we normally use, which means we list them in x, y, and well, there's no z here, but the point remains. So y1 is 3, and this is equal to negative 3 over 4 times x minus 5. So y equals negative 3 over 4 x plus 15 over 4 plus 3. Now you will notice that very often you will see these problems with improper fractions. Why do you think they are usually, well, they often come in improper fractions? It's because it's just much more convenient than having to simplify to partial fractions and then going back. Like whole number and then a fraction and then going back, well, that's annoying when you have to do further calculations. So very often you will see people just listing them something like this. Now, this next problem, we just go straight into the substitution step because we've already written out the equation up here for our memory purposes. When you encounter a problem, listing out the equations that you think you'll need really quickly before you happen to forget any of them is a very good idea. Of course, that depends on you recognizing that you need those equations first. So obviously, the first most important skill of math is identifying what you need, just like in life, really. So math teaches you many essential skills that you will use in everyday life. And not just in, say, grocery shopping math either. So, here we have y, well, minus y1, so minus negative 3. So this is equal to 3x minus negative 1. And this is equal to 3x. This is minus negative 1. That's plus 1. So 3x plus 3. So we see that the plus 3's can just cancel out. So y equals 3x. Now wait a second. Did we forget something important in the problem? By the way, this is part of why multi-part problems are a little bit harder to mess up on than single-part problems. It is very, very easy to, once you've solved most of a problem, accidentally forget the last little bit, as you may have noticed, and if you did, good for you. So, write each equation in standard form. I mean, yes, we know that slope y-intercept form is much more common, and honestly it should be standard, and usually it is treated pretty much as standard, but the standard form is ax plus by plus c equals 0. So that means that, oh look, we're going to have to make some room. Most teachers will accept a dashed line, assuming your columns are not too close together and that it's really obvious. So this transforms to 3 over 4x plus y minus 27 over 4 equals 0. Now you might be thinking, hey, weren't you just saying that they don't have to be integers? Well, yes, but we'll do that now. Trying to do too many steps at once often causes very dumb mistakes, which means that you should only really do that when you are very, very confident. So here we would have 3x minus y. If you subscribe to the x should have a positive coefficient, equals 0. Of course, if you don't, you're free to say negative 3x plus y equals 0. The same result anyways. Alright, this next one, we have, once again, y minus y1, which is minus negative 3. And this is equal to slope, so negative 3 over 4 times x minus x1. So, that means y plus 3 equals negative 3/4 x plus 3 over 2. Alright, so what does this give us? Well, we can move these over because instead of simplifying to slope y-intercept form, it never said up here that we should write the equation of the line in slope y-intercept form first. It said write an equation of the line, then write each equation in standard form. So most teachers, because despite the wording of the then part, will allow you to go straight to the finish. Which means, in this case, admittedly, this is not quite to the finish yet. Now, often there is a habit of people to start with the equal sign and then write to the left. Why do you think that is? It's because it's a little bit hard to gauge whether or not you have the right spacing to fit everything inside if you wait. And then your equal signs might end up wandering, so to speak. And that is generally considered to be very, very ugly. Math is an art form, and admittedly, we all know that some very ugly pieces of art are very famous, but that's not our point. That's not what we're trying to do, at least. So, 3x plus 4y plus 6 equals 0. Alright, next example. So we're writing some equations of some lines, passing through some points, and we're then writing them in standard form. Each grid is 1 unit. Now, if it didn't specify, that would have been the default, but it specified, which is great. So, here we have the x-axis and the y-axis. Sometimes teachers will leave the axis labels out on purpose so that you can label them yourselves. So 2, 4, 6, 8, and 0. And 2, 4, 6, 8. Alright. So, L4. Well, the 1 point that we have for L4 is negative 1, 1. And for L5, the point we get is 6, 4. For L6, it is 6, 2. For L7, 3, 1. Alright, so how do we find the slopes? Well, we find them by basically looking for another point. So here, that would be this point right here. And for L7, well, the slope is pretty obvious, undefined. It's just x equals something. Now, for L5, well, we see that this point could work, or this point here, or that point up there, but we won't mark it. For L6, the slope is clearly 0. So, L4, we get the point was negative 1, 1, m equals, well, technically we could use either formula for this really. Since we have to find the slope ourselves, we could just use a 2-point formula, but we'll do that in later examples. So here we have 5, 8. Okay, so that's a matter of going across by 6 units and up by 7. So, rise. That means y2 minus y1. So, 8 minus 1 over 5 minus negative 1. And this is equal to 7 over 6. So, we have y minus y1 equals m x minus x1, which gives us, well, y1 is 1 and x1 is negative 1, so y minus 1 equals 7 over 6 x, well, minus negative 1. Because on the substitution step, really, we aren't exactly supposed to flip all the flip signs and such, although many people do it anyway, and most teachers will let you get away with it. Most. Make sure you know what your teacher wants. Now, so, here we would have 7 over 6 x, and here it's still y minus 1, so plus 7 over 6, and thus if we move these around we would get, well, we're going to shift the equal sign because there's not enough room over there. 7 over 6x plus 13 over 6, because that's what adding 1 to this does. And wait a second, really this is not quite the right order, right? Because it should be ax plus by plus c. We're beginning a second column. So on the second column, we have 7x minus 6y plus 13 equals 0. There. That's standard form. And then for L5, we have clearly the slope is, well, for every 2 units over, you go 1 unit up, so the slope is 1/2. So we start with the point 6,4. Usually, many teachers, instead of colons, they prefer if you use a bracket to start each sub-question. But it depends on the teacher. Why is bracket instead of colon? It's because colons could be a ratio, whereas a bracket with no corresponding left bracket, well, what is that? It's surely not multiplied in. So we start with 6, 4, and m equals 1/2. Now, write each equation in standard form. We start with, of course, y minus y1 is 4. And this is equal to slope multiplied by x minus x1, which is 6. Now, y minus 4 equals 1/2 x minus 3. So, if we wanted to keep the equal signs in one place, we do have enough room where we could just do this. Minus y plus 1 equals x minus 2y, and then plus 2. All right. This is standard form, even though the 0 is on the other side. Really, nobody will care. For the most part, nobody will care if you write it like this. And for L6, we have a flat line where y equals 2. So in standard form, this is y minus 2 equals 0. And that's it. For our 7, well, we see that clearly x equals 3. Which means that the standard form is going to be x minus 3 equals 0. So here, whatever the y value is, it doesn't matter. It just ends up being x equals 3. And here, similarly, whatever the x value is here, well, it doesn't matter. It's not in the equation. So y is still going to be 2. Another example. Write an equation of a line that passes through each pair of points. Now, what was the formula? We know that it derives from y minus y1, and this is equal to slope multiplied by x minus x1. So what's a slope? Slope is rise over run. Rise over run is change in y over change in x. So, here, that means, well, y minus y1, let's have this be 1.1. So 5, this is equal to y2, which is negative 3, minus 5, over x2, which is 3, minus x1, which is 1. And multiplied by x minus x1, which is 1. So here equals negative 3 minus 5, that's negative 8, over 2 times x minus 1. So y equals negative 4x plus 4 plus 5. Now, we do not necessarily have to make it standard form because the question doesn't tell us to. So we leave this in slope y-intercept. Does this make sense? Let's look at the slope. Okay, negative 4x. That means that as this goes up 2, this should go down 8. Yeah, okay, fine. And plus 9. Well, here we have 1, 5. So 9 minus 4 is 5. Okay. Next question. We have negative 2, negative 3. So y2 is negative 9. And that means y minus y1. y1 is negative 3. And equal sign negative 9 minus negative 3 over 1 minus negative 2 and x minus x1. So x minus x1. And here that means y plus 3 equals negative 6 over 3, because 1 plus 2 is 3, as we learned way back in what, grade 1? Or earlier even? Most likely earlier, because like getting candy and stuff, we know how to count candy. So, times x plus 2. Alright. What does this do for us? So negative 2 times x plus 2 minus 3. Y is equal to negative 2x minus 4 minus 3. Negative 2x minus 7. All right. Next example. So we need to write equations of the line that passes through each pair of points, then write each equation in standard form. So we have L9 and L10 marked. So what are these points? Well, okay, so we don't have a scale, and therefore, usually when you don't have a scale, the convention is to assume that it's one grid equals one unit. So here that would be 2, 4, and here 5, 5, and here 6, 1. So the formula is writing out the formula to begin a question may sound annoying and tedious and all that other stuff, but, well, it's good practice, at least when you first begin learning a particular way of doing things. We do point out that if you use extra brackets, as long as it doesn't affect the problem, most teachers will not care, and if you're on a rush for time, feel free to not erase them, because often it's basically a reflex for a lot of us. So, here for L9, that means y minus y1. Let's use this common point as y1. Or just 0.1. This is equal to y2 minus y1. y2 is 5, y1 is 4. 5 minus 4 over x2 minus x1. So 5 minus 2. And times x minus x1 is here 2. Alright, so that leads us to y equals 1/3 x minus 2 plus 4. One-third x minus 2/3 plus 4. So really, most of us can just write this. I mean, yes, okay, it's not so good really for most of the time to write mixed fractions in case you have to calculate further or do something. But in this case, if this is it, well, if you have a 4 and then you're subtracting 2/3, it's kind of even more annoying to write a improper fraction, 10/3. Personal preference, really. And even among teachers, a lot of this stuff is actually somewhat personal preference. Now, L10. L10 is this line here. So, y minus y1. What's y1? y1, we are using still this one for 0.1. This is equal to y2, which is 1, minus y1, which is 4, over x2, which is 6, minus x1, which is 2, times x minus x1, equal to -3 over 4 x minus 2 plus 4. So equals -3 over 4 x, and then plus, well, 3 over 2, because you can cancel out a little bit, plus 4. So negative 3 over 4x plus 11 over 2. And, well, that's it. Because we don't have to put this in standard form, do we? Oh, yes we do. Which is why we should always go back and read the question again after you finish. Because you may have noticed that quite often in these questions, there will be, oh, they want a particular form. Which means that quite frequently what you end up doing might not be exactly what they're asking for. If you learn to reflexively do it in standard form, well, wait a second. The question wanted slope-intercept form. So what are you doing? All right. So after we have this, it's not very difficult to go to standard form because that's why I left the space up here. So, well, okay. Let's do the moving and then do the whole integer work. So this is standard form, even though the 0 is on the other side, usually. Or at least most teachers will accept that this is standard form. Now here we can just move this over. Make sure you do not become confused with whatever graphs you are working beside if you write them particularly close. Some teachers don't like dashed lines, so be careful on that too. Wait a second, something is a little bit off here. It's because the y should be in the middle, really. But since we're not at the last step yet, very few teachers will actually care. On the other hand, depending on personal habits, you might find it's easier to just move the whole thing over like this, or move them over one by one. Writing it like this kind of reduces the chance that you will forget the last part, but writing them one by one means that it's less likely that you'll forget to flip them back over for the final answer. And some people are picky about format, at least for the final answer, and maybe for more. Plus 4y minus 22 equals 0. So, that's it for this problem. And for this section, actually. So we'll get into a little bit more new stuff for grade 10 with regards to linear equations in the next section.